All right, everybody. Good morning. I want to welcome you to our May webinar for the Lake States Fire Science Consortium, and we're co-hosting this with the LANDFIRE team. I'm Jack McGowan-Stinsky, and I'll be moderating the webinar this afternoon. Just a brief info about the Lake States Fire Science Consortium. We're funded by the Joint Fire Science Program, and we're one of 15 regional consortia or fire science exchanges across the country. Our mission is to accelerate the awareness, understanding, adoption, and sharing of wildland fire science information by federal, tribal, state, local, and private stakeholders across the Lake States and the adjacent Canadian provinces of Ontario and Manitoba. We're using an Adobe Connect webinar interface, and so if you want to interact with any of the attendees or ask a question, please use the chat box. It should be located in the lower right-hand portion of your screen, and we'll keep an eye out for those questions. And we ask that if you have questions throughout the webinar, please go ahead and ask them rather than waiting until the end, and Randy can address them. So let's get on to today's webinar, Making It Work, How Michigan National Forest Modified Landfire Data for Local Use by Randy Swaty. Randy joined the Nature Conservancy's Michigan chapter in 2002 as a forest ecologist tasked with working with a variety of owners of large landscapes to promote sustainable management practices and leading the Landfire Rapid Assessment effort in the Lake States region. The scientific specialties cover spatial scales ranging from community genetics to mycorrhizal ecology and landscape scale planning. Randy joined Landfire full-time in 2007 and has covered a variety of bases, including working to improve forest certification standards, participating in conservation area planning, serving on the Conservancy's forest management SOP team, and contributing to the global fire assessment. He develops vegetation models and applies Landfire products within and outside of the Conservancy. He facilitates workshops and seminars on the use of Landfire data and products and is one of the leaders of the Biophysical Settings Review Project. Randy grew up in Little Rock and earned both bachelor and master's degree at Northern Arizona University in Flagstaff. He splits his time between Marquette, Michigan, and Evanston, Illinois. So with that, let's get to the webinar. Go ahead, Randy. Take it away.
All right. Hello, everyone. Randy here. I wanted to start out with a quick story that I think sort of highlights what we're going to talk about today. Way back in 1987, my father gave me an old Plymouth Horizon, a brown one. It was free and got me to work and back. But of course, being a teenager, I had to modify it. I added Pirelli tires, a JVC stereo, a roof rack. And well, I basically modified it to suit my needs. When it needed repairs, my dad would simply hand me his keys and say, my tools are in the trunk. Good luck. If I got in a real bind, he'd help. And in a way, that's what the presentation is about today. Taking free, widely available Landfire products, then modifying them to suit your local needs. One small difference between folks with Landfire and my father, we'd like to help you before you get in a bind. So today we're going to go through a quick introduction to Landfire. I noticed several of you on the participants list have worked with Landfire before, so we'll make that pretty quick. Then we'll jump right into 3 examples in Michigan of how people are modifying Landfire data for their work. As we go through the slides, I'm hoping you'll ask questions in the text box. By the way, I'm curious, did any of you receive an announcement of this webinar referring to me as infamous? Well, it's a great word meaning disrespectable, heinous, villainous, or wicked. Yes, that's me. Think serial killers. Anyways, putting on my infamous hat, I'll implore you to hit up the chat box. I can watch that and answer questions and participate that way. I do have many of your names here, just saying, so I could even call out on you. So Landfire is a partnership between the U.S. Forest Service and the U.S. Department of Interior aimed at mapping all things, or at least most things, vegetation, past and present. As you might guess from the name, Landfire also delivers several fire-related data sets as well. The photo on the left includes many of the folks who actually do the hard work of mapping the Landfire data sets. They're with the Landfire program scattered largely through Montana, though they're not all in Montana. Some are in Sioux Falls, South Dakota. The Natl Conservancy has a cooperative agreement to assist users to glean feedback and to provide outreach. We're pictured on the right and have expertise in fire ecology, GIS, climate change, state and transition modeling, science communications, and conservation planning. And I'm the guy on the right with the beard. And then I wanted to note a few things here. There are some true experts in this process on the webinar today, such as Don Helmbrecht. Corey Blankenship of our team has also kicked in a lot of information to help people do this process. And I also want to call out my colleague Jeannie Patton, who at the last minute converted these slides to make them 508 compliant. I kind of put her in a bind, so I want to call her out. But I'm sort of the messenger today, and want to connect some dots for you as you do your work out on the lands of America. As way of introduction, I'm going to go through just a few slides that give you some of the traits of the LANDFIRE spatial data. First, it's wall-to-wall, which is and has always been really exciting to me. I first started out in the Upper Peninsula of Michigan, where we didn't have wall-to-wall data when I started, and questions that we wanted to address on, say, private non-industrial lands, we had to guess about, we had to make assumptions about. And now we have LANDFIRE data that's not just Forest Service, not just BLM, not just the Natl Conservancy, it's all lands, including Alaska, Hawaii, and the insular areas such as Puerto Rico, American Samoa, and Guam. LANDFIRE was developed for and is especially well suited for working across state boundaries, situations where one state or area may not have data or may not have data that can be used together. So that's to say it's for large-scale work, not for work in your backyard. Another trait of LANDFIRE data is that we use consistent methods across the country as much as possible. We do this so that LANDFIRE data can be used across large areas. And there are important exceptions to this. Sometimes we do try to add in additional information to better map in a certain area. For example, with the biophysical settings data set that I'll describe in a moment, we leaned more on soils in the east than in the west for mapping. So it's a fine line between trying to be consistent and taking in the best data we can and using the best processes for an area. Also, as I mentioned earlier, it's designed with a purpose, that is large-scale work. It was born out of a need for national data to help prioritize management and to provide decision support. It was designed for use over large areas, as I mentioned. Although LANDFIRE was designed with fire and fuels management in mind, uses out on the internet and by people like yourselves range from fire behavior modeling to sage grouse habitat mapping to siting of wildfire camera traps, assisting restoration of riparian corridors, and much more. Currently, there's almost 1,000 articles citing LANDFIRE on Google Scholar. So people are doing a lot of creative work with LANDFIRE. Most of it, I assume, we don't even know about. Also, importantly, LANDFIRE data is improved and updated over time. We, quote, refresh the data biannually, meaning we go into the national or original LANDFIRE data and update it based on disturbances and other information. We are in the midst of a remap, which will be a total remap of the data sets using the latest imagery, bringing in LiDAR information, Landsat 8 information. So I'm really excited about that, so watch for that. To improve it and keep it updated over time is expensive. We learn more with every iteration and do our best to make improvements and incorporate new techniques over time. However, we do have currently shrinking budgets, and there is a production schedule that we try to meet partly for your needs, and so we don't always have time to incorporate all improvements. So to summarize, LANDFIRE is really good at some things, in particular the national and regional level planning and prioritization that it's designed to support. But as someone who's worked with LANDFIRE data for 10 years, I'll be the first to admit that LANDFIRE is far from perfect. The rub is that there's a great need for data at finer scales, and so we have to localize or modify data for those more local uses. That's sort of the focus of what we'll talk about today. Here is a shortened list of LANDFIRE data sets LANDFIRE delivers more than 24 spatial data sets, and in the interest of being legible, I only list some here. Most LANDFIRE data sets are in grid format with 30-meter pixels. For the lower 48, there are roughly 9 billion pixels that LANDFIRE folks try to label. So just for a moment, just cogitate on that. 9 billion pixels for the lower 48 that we try to label with a existing vegetation cover, height, or type label, or a disturbance label, or a fire behavior fuel label. It's really difficult, and it takes a lot of people and feedback from users like you to help keep it current and to make it as good as it can be. Today we'll largely focus on the fire behavior fuel model data sets, specifically the 13 Anderson and the 40 Scott and Bergan. And I'll admit again, this is a stretch for me. I've leaned a lot on presentations given by Don Helmbrecht, information from Megan Sabaski, Persephone Whalen, and Corey Blankenship and others. So yes, please hit the chat box and we'll try best to answer questions if I confuse you in any way. As many of you know, the fire behavior fuel models are sort of a stylized set of fuel bed characteristics used as input for a variety of wildfire modeling applications. The fuel models define input variables for a set of quantitative vegetation characteristics that can be visually identified in the field. Depending on local conditions, one of several fuel models may be appropriate. Hal Anderson, a fuel model fire behavior pioneer, stated back in 1982, that fuel models are simply tools to help the user realistically estimate fire behavior. And this is the key part of his quote here, and again I'm quoting, "The user must maintain a flexible frame of mind and an adaptive method of operating to totally utilize these aids." I think that's true whether you're using a hammer or LANDFIRE data. I think it's a great quote. Again, we have to remain flexible in our frame of mind, review the data, and use common sense. Where LANDFIRE delivers these data sets, and I'll show you some maps of those in a moment, and I'm going to introduce this tool called the Total Fuels Change tool that local managers can use to update and modify the fuels data for their own uses. So the original 13 fuel model, fire behavior fuel models were built from Al Binney's 1976 original fuel models, and again developed for use in fire spread models. Lots of models there. They were designed for the most severe period of the fire season when wildfires pose the greatest control problems. They were designed for use in the dry season and are not dynamic. So, and a major advance, a major contribution, and they were built on, the concept anyway, was built on by Scott and Bergan, who developed the dynamic fuel models, which were published in 2005, to eliminate the assumption that the fuel bed was uniform during the dry season. These models aim to move away from the correlation between vegetation type and fuel bed characteristics. For example, the original chaparral model becomes the heavy load tall brush model. They're also crosswalked to the 13. So when you go to the Scott and Bergan manual, you'll see the original 13 models as 1 to 13 to allow backwards compatibility in newer modeling software. So a great advance published in 2005, and I would love to see in the chat box how many people use the 13, how many people use the 40, or branch out to other fire behavior fuel models for information. So a few maps just to first orient us to where we'll be looking today and for you can get a sense of the data sets. Here's the 13 Anderson fire behavior fuel models mapped for most of Wisconsin, part of Minnesota, and Michigan. Those polygons represent national forests that we'll be talking about today. Here's a representation of the 40 fire behavior fuel models, and you'll see there's obviously more colors, more differentiation, and a legend that's pretty long, but it's more detailed and again dynamic. Okay, here's the basic, very crude outline of the process. So basically, you take a combination of existing vegetation type existing vegetation cover, existing vegetation height, sometimes the biophysical settings or historic ecosystems, and for updated data sets, the fuel disturbance, apply a rule set to get the fire behavior fuel model. So to me, it's a really fascinating data set, and it's based on rule sets that were developed by fire and fuel specialists through a series of fuel calibration workshops held across the country. So just a quick tour of the inputs. Here I have LANDFIRE's existing vegetation type set at 60% transparency behind the east block of the Hiawatha National Forest, and with agriculture, recently burned, recently logged, plantation, sparsely vegetated and developed pixels brought out to the fore in this map just to highlight those. Partly as a way to say this is existing vegetation type, not potential. Also, I'll note that I have done some grouping here. There are many labels for agriculture and many different labels for developed. So again, I've grouped those together just to say ag or developed, for example. The legend would be many dozens, would have many dozens of labels just for this extent if I were to bring in the entire legend. It's a mid-scale classification built off NatureServe's ecological systems. LANDFIRE also delivers existing vegetation height. And I have, for your enjoyment, provided the full legend here for the area darkened, again, the eastern block of the Hiawatha National Forest. And you'll notice, you'll start to see the complexity of the landscape on the Hiawatha. It gets more complex as we walk through some of the maps. In the future, we hope to make smaller bins or categories for forest height. For example, we have forest height, a forest height bin ranging from 10 meters to 25 meters. We hope to break that up in the future. Or this might be something you add to with your local data. Because sometimes we need more details than are provided by LANDFIRE. Here's the existing vegetation cover map provided by LANDFIRE. A longer legend here with split into herbaceous, shrub, and tree, as you see. Again, the heterogeneity and the complexity of the Hiawatha National Forest starts to jump out even more here. I point that out because it makes it really interesting to work here and really complicated, and it takes a lot of input and a lot of work to get things right in such a complicated landscape. Importantly, LANDFIRE delivers multiple disturbance data sets. We get disturbances from multiple sources. We mine the disturbance databases that you guys contribute to. We take in user-submitted polygons, and we use remote sensing techniques to map disturbances. Have you reported a disturbance today? I should have a bumper sticker saying that. It's really important that we get your disturbance information. As we do our 2-year updates, disturbances are key to changing the other data sets. This map represents some disturbances for the area going back 10 years. Another thing I would encourage you to do is look at the southeastern United States. You can pick up the tornado paths. It's really scary, really fascinating. And finally, another input that's sometimes used to map fire behavior fuel models are the biophysical settings, which represents the dominant vegetation on the ground prior to a major European settlement. It's a model data set based on environmental inputs such as slope, soils, superficial geology, and climate parameters. In some parts of the country, we check this against General Land Office notes and the biology of what we know for these ecosystems. To me, this is a really useful and again, fascinating data set, really hard to create. It's developed to capture a system, not just one point in time, so it's not always easy to crosswalk this to General Land Office survey notes, which were one point in time. Okay, I'll show this slide again so you can kind of reimagine how the fuels are created. To me, it's an amazing data set, super difficult to create. With the fuels data, there are several places where improvements can make a difference. So if you can improve the existing vegetation type data, or the fuel disturbance data, or the rule sets, or any of the inputs, you'll get better fire behavior fuel model data. And that's what folks on the Hiawatha, the Huron, and many other places across the country have done. They've taken sort of the Plymouth Horizon from 1978 and modified it to make it suit their needs, which to me is very admirable, creative, and important work. Here's just a quick example of what can happen. In this map, you see the red line. Those are LANDFIRE map zones. So to the north of the red line is the Upper Peninsula of Michigan largely and map zone 51. To the south of the red line is largely Wisconsin. The green line represents the Ottawa National Forest. And this is the LANDFIRE Scott and Bergan 40 fire behavior fuel models. And you'll see an abrupt change right at the map zone line. I've looked at most of the inputs to the fuels data, the existing vegetation type, height, and cover. And to me, it looks like the rule sets were different between map zones 50 and 51. I don't know which one was right. And it's difficult because, you know, when you're mapping across a map zone, which is roughly the size of a state sometimes, you're kind of taking an average of that map zone for the fuel rule set. So for work on the Ottawa, we'll be adjusting this to meet their needs. So this is just an example of what we might need to do. So again, to orient you to our three examples, we have the Huron-Manistee fuels modification in the Lower Peninsula of Michigan, the Hiawatha National Forest fuels assessment on the eastern half of the Upper Peninsula of Michigan, then the Ottawa National Forest. Just a really quick preview of work to come over in the western Upper Peninsula. So in a slide, a figure by Don Helmbrecht. Again, I want to shout out to Don. He's on the call today. Thanks for this, Don. I stole it from the Fuels Modification Guide or the Data Modification Guide, I believe. Importantly, you define your objectives. This is really key, and that's difficult. You guys all are balancing multiple objectives on your landscapes. So it's important to talk this through, and it really impacts what you do when you calibrate the fuels or you adjust data. If you're just thinking about treatment of hazardous fuels, you may put more effort into some veg types and less effort into others. So it's important to define objectives. You got to identify the data requirements to do the calibration, critique the rule sets and data. You modify it and analyze the results of your modification. And today we'll show you some quick screenshots of ways to do this fairly quickly. People who have gone through this are probably shaking their heads, but compared to starting from scratch, this process will be a lot faster than starting from scratch. Okay, a beautiful picture from, I believe, Persephone. If I'm miscrediting this to her, please let me know. This is, to me, again, a beautiful picture of a prescribed burn in the lower peninsula of Michigan. So they did a calibration with the fire behavior fuel models. Her presentation of this project is available in the resources we'll provide after this webinar. Also in those resources, you'll find presentations from Megan Sabaski, who provided tons of information for the presentation today and has tons of resources, and from Robert Zeal, also known as Zeke, on how to select appropriate fuel models. We can share those presentations with you, so watch for an email after the webinar today. So here are the basic steps that the Huron went through. After looking at their objectives, they updated the LANDFIRE disturbance data. Excuse me, I'll show you maps of that. They updated some of the inputs, for example, the existing vegetation cover. They critiqued the mapping rules, and they conducted preliminary fire behavior modeling to evaluate the data modifications. Okay, so one of the first things they did is to update the disturbances. So here's a screenshot of that. On the left are the LANDFIRE 2008 data for the area of interest. And you'll see that they modified that data, and we've circled a couple spots there for you to check out. This is an important step because that really keys into what fuels are on the ground. And LANDFIRE does an amazing job, I think, of capturing disturbances, but we do miss some. Additionally, it's also useful to review how LANDFIRE labeled disturbances. If we didn't get a polygon from somewhere that had that disturbance label, we have to assign that. And again, remember, there's 9 billion pixels that we're looking across. Of course, not all those are disturbed, but there are many disturbed pixels, and ones that we have to do manually. It's very difficult. So we suggest that you review the LANDFIRE disturbances and add in your disturbances as possible. This is for the Huron, but also they've done a similar process with Don's help on the Hiawatha. So here's a screenshot of the LANDFIRE total fuel change tool. So imagine this. Imagine you have your experts ready to help. You have modified data sets such as the disturbance data, or you have better existing vegetation type data, whatever the case may be, and you want to review how LANDFIRE assigned rules, and then you want to modify that. You use this tool. It's an ArcGIS toolbar that allows users to translate that knowledge and data into spatially explosive fire behavior fuel models. Again, here's a screenshot of that, and it's pretty clever. It's pretty clever. So some examples on the Huron-Manistee include this one, to undisturbed Laurentian pine barrens. At the top, you'll see the original LANDFIRE Map Zone 51 rules, Map Zone 51 largely covering Michigan. You'll note for the Laurentian pine barrens, anytime they mapped that type and had a range of tree cover essentially from 10 to 100% and a range of height from 0 to 50 meters, it was labeled as the fuel type GR3, right? So it's just a rule set defined by in LANDFIRE calibration workshops. On the Huron-Manistee, they decided to split out this combination. So when you had cover of Laurentian pine barrens, range 0 to 50 meters, that was 10 to 39%, you would get a GR3. It would remain GR3, that is. If you had more cover, 40 to 100%, it was relabeled as GS2. So they went through a calibration workshop on the Huron-Manistee, changed these rules in the total fuel change tool, and got these results. Then, using the compare models for spreadsheet obtainable on the Pyrologics website, you can do quick comparisons such as this. Again, this is a really simplified example of how you can do some quick checks of how those changes to the fire behavior fuel models might translate the changes in fire behavior. So here we have flame length on the left, and you see that the purple is the GR3, the yellow is the GS2. And this is just a made-up graph with some, numbers in these drop-downs just to show you how this can work. So we have some relatively quick tools such as the total fuel change tool and this spreadsheet developed by Joe Scott and his team at Pyrologics to do this work. All right, so you remember that, and I could call on people. I guess I won't, okay. You have existing vegetation type, height, cover. If you're looking at LANDFIRE updated data sets, you're going to have disturbance, and you might use biophysical settings to help split out the fuel models. You might also want to bring in what's called a wildcard. And I'm going to oversimplify this. But basically on the Huron, they brought in what I'm calling sort of a management disturbance data set. And this was important to them to help split out some of the fire behavior fuel models. So in this example, for, the orange pixels are labeled as broadcast burns. So LANDFIRE may not have split those types out, but they did on the Huron-Manistee. And here's how it worked in the total fuel change tool. On the top, maybe you're getting oriented to this by now. We have the Laurentian pine barrens with a disturbance. They've been disturbed, and they've got this split of tree cover from 10 to 59% trees, 0 to 50 meters. And just based on this information, the fuels are labeled as GR3. Here, bringing in the wild card that you can see below, it's the columns labeled wild. They connected in, if you will, the wildcard data set or the locally developed management disturbance data set to further refine those fire behavior fuel model labels. So again, there's a question in the chat. Thanks for that. Parameter in the Laurentian pine brand had a fuel height labeled as 0 to 150 meters. Right, there must have been a typo or I misspoke. There should not have been 150 meters. I apologize for that. Right, good point. Thanks for that comment. Okay, so meaningful changes were made to the fuel models, meaning in this case that we had quite a few pixels relabeled after the calibration. You can see the change here. The largest changes were from GR3 to GS2, GS3 to TL2, and TU2 to TL2. And you can go in and do fire behavior fuel modeling or go into the spreadsheet I showed you before to find out what the implications of that are. But to me, it's a great refinement to see, and again, I believe that this was a lot easier than starting from scratch. So a summary of the Huron-Manistee National Forest. I hope I've given you a sense of how people use LANDFIRE data and perhaps even inspire you to give it a go. It's not perfect on all landscapes. But for example, on Huron-Manistee, they needed to adjust the LANDFIRE fuels. They needed to update the input data and the fuel rules. They held a workshop, and there was a fair amount of work done before the workshop, I am sure, to bring in all the data and to make it meet their needs and get it all massaged for the LANDFIRE Total Change tool. And I've been to one of these workshops on the Hiawatha, and it's pretty fun. You're just debating the fuel rules and looking at the spatial data and making adjustments. I was telling my family last night, it's kind of weird. We're kind of trained as scientists not to monkey with data or mess with it, but here you need to. You need to review it and massage it. It's a different thing than massaging data for your thesis or something like that. This is making the data fit your needs, which is what we should do. If you want to know more, there are tons of resources. Megan Sabaski and Persephone Whalen have been super generous in sharing information. As I mentioned, Don and Corey have literally written the guide on modifying LANDFIRE data. Megan has a Google group. Landfire.gov has all the data sets. It's very robust, a very robust set of resources. And we're going to send out links after this for you because I know it's a lot of information. Okay, jumping to the Hiawatha Fuels Assessment. Like all national forests, the Hiawatha has many objectives. With the fuels assessment that's currently underway, the staff on the Hiawatha are not only trying to prioritize where to treat hazardous fuels, but they're also working to better understand the fire ecology of the area and to identify areas where they can increase resiliency to climate change and other threats. And hats off to all you guys managing these lands that have so many objectives, and you have to try to mash it all together. It's not easy. So for this work, we're modifying the fuels data based on a calibration workshop. We're modifying the biophysical settings, spatial data, and input models to better understand what the landscape was like historically. We've also reviewed existing vegetation type, height, and cover, which, as you now know, feed into fire behavior fuel model mapping. So I'm going to go at this a little different. Since I've given you a tour of the tool, I wanted to just present things in a little different manner on the Hiawatha. We've had some changes, pretty significant changes to the west, to the entire Hiawatha National Forest. Here are the top 5 changes for the west side of the Hiawatha National Forest. And for those of you who know fire behavior fuel models, you get a sense of what the implications are. For folks like me, I would go into that spreadsheet I showed you earlier to explore this. but some types had, up to 30,000 acres changed, which is meaningful. And roughly 20% of the Hiawatha National Forest changed as a result of the fuel calibration workshop. The dark purple-gray pixels here represent that 20%. And you'll notice it's across the Hiawatha. There are some concentrations, but you see changes made north, south, east, and west. So it's been, I think, a meaningful process so far, and it's illuminated some gaps in our understanding. On Hiawatha, just like all assessments, I believe, it's about more than fuels. Again, I'm greatly oversimplifying all of your work. On the Hiawatha National Forest, we're also interested in looking at reference conditions, or how did the ecosystems of the Hiawatha look and work prior to European settlement. So they're bringing in outside researchers and data to better understand how their ecosystems would have worked historically. To start, they have provided feedback on LANDFIRE's biophysical settings models to me, which incorporate disturbance information to estimate how much of each ecosystem's or each biophysical settings succession classes would have been on a landscape historically, right? So we might take those Laurentian pine barrens, break that biophysical setting up into multiple succession classes based on height and cover largely, then try to model how much of those would have been on the landscape historically based on natural disturbance regimes. In this screenshot, you see the modeling software called SynchroSim. The boxes represent succession classes. The lines represent succession or disturbance. We're working together to modify this LANDFIRE model and all of them for the ecosystems of the Hiawatha to better represent their knowledge. And again, as I mentioned before, we found some holes in our knowledge. For example, the Hiawatha is just incredibly complicated with these red pine, white pine islands in the middle of these boreal acid peatlands. And it's there's been tons of work at Swaty National Wildlife Refuge, but things are a little different there in between the Hiawatha blocks. So the Wisconsin DNR is generously and wonderfully coming up and doing tons of work on the historic fire regimes there. Also, Michigan Tech is taking soil cores to look at the historic fire regimes of the boreal acid peatlands. So what do we do with this? We use the models to get at how much of each succession class would have been on the landscape historically, represented in blue. Then we map the current spread or amount of those succession classes represented in red. As you guys probably all know, the jack pine ecosystems are incredibly fire dependent. And most of that ecosystem would have been open canopy or even grasses and jack pine seedlings historically. Today we have mostly closed canopy jack pine. So when you see this, you're probably thinking this right now. It's probably happening right now with you. You're probably wondering, wow, are those models correct? Did LANDFIRE map current conditions correctly? And then if so, who cares? Those are really important questions. Maybe we've managed towards closed canopy jack pine on purpose. Maybe there are values associated with that or other reasons why we've done this. So we do this work to set the stage for meaningful conversations and to identify gaps in our understanding. So for the vegetation departure inputs, we're refining the models and again using information gleaned from Michigan Tech and the Wisconsin Department of Natural Resources. Staff on the ground have reviewed the existing vegetation type, height, and cover data, and we're going to be changing some of those pixels. And I'll leave it to them to address the so what question. But it's really important when you compare historic to current, especially in the face of climate change, resource extraction, and all the modern things that we're dealing with on the ground today. LANDFIRE is not here to say that reference conditions are desired future conditions necessarily. So a summary of this, The Hiawatha work is in progress. It's a multi-year project, and it's just been so exciting to see the infusion of input in the last year from those external partners. We have multiple stakeholders, as I've mentioned, and it takes that. It's really amazing how little we know about some of our ecosystems and how much more we can learn through this work. Also, we're doing a rapid assessment of the Ottawa National Forest fire fuels and vegetation, which is beginning this summer. And I want to go through this really briefly just to inspire you to consider doing something that's similar. So here's the Ottawa National Forest on the western part of the Upper Peninsula. Basically what we're going to do is we're going to just take base LANDFIRE data, calculate vegetation departure, assess the vegetation on the landscape, possibly going outside the ownership boundary or the proclamation boundary as deemed appropriate by folks on the ground, to just get a sense of what's there and to get a better understanding of the LANDFIRE data. We'll then run LANDFIRE data through probably multiple modeling frameworks to assess just fire behavior in a crude way. Then we'll have outputs that we can get review on from experts on the ground and other stakeholders. We're figuring it'll take this summer to get that done, but it's not super difficult. The data is there. If you know how to do some basic raster processing, you can do this. And Corey Blankenship of our team has made several YouTube videos on how to do this sort of thing, and our team stands ready to help you. And it's really fun. If you love data like I do, it's really rewarding to process the data and find out how we can make it better. Another thing that you can do to test what you've done, I wanted to show this really quick. You can use IFTDIS. I love these acronyms, the Interagency Fuel Treatment Decision Support System. And this is a slide contributed by Megan Sabaski, which is made up inputs in a way to run the basic FLAM map. It's a modeling software that's in the IFTDIS support system. And you can fairly quickly model out and check out your differences from your calibration workshops. So I'll be toying with this summer on the Ottawa, and we'll probably do some similar things on the Hiawatha as well. From what I've heard, the IFTDIS staff is super helpful, super friendly. I've just heard great things about this interface, so I encourage you to check it out. Get an account and give it a go. And I think it's probably one of the better broad, free experimentation modeling decision support systems out there. Okay, so with all that, I've given you just tons of information. I've just oversimplified things. I so apologize for that because I know there's just so much more to all this than we could cover today. But I wanted to kind of tie things together here with a little bit of perspective provided by a LANDFIRE business lead, Henry Bastian, who's also on the call today. So Henry, I'll tell you, we have shortened your quote a little bit. But I'll let you read that for a moment and take that in. And the basic point for me is that it's all about your perspective, what your objectives are, and how you intend to use the data. My guess, and I could be so wrong on this, but if you're like me, you made it through graduate school without ever having to make a map. Maybe not even really reviewing a map. Or if you made a map, it was assembling data that other people created. Most of us have not created spatial data or taken Landsat imagery and tried to label it. We just haven't done that. I've been really impressed with people on the Great Lakes who have taken the time to learn and understand these data sets and have developed a broad perspective of what they're used for and what their strengths and weaknesses are. That's so important when you're looking at hundreds of thousands or millions or billions of pixels. You need to do your homework to understand a perspective, and that may be one of the most important things you can do, is understand the strengths and limitations of a process, of the data, of your approach. And I think that Henry's quote here gets at that, just like the quote by Hal Anderson earlier did. And on this page as well are sort of a tease for you. We're going to, again, send around a document in the next day or two that highlights and gathers resources that I've mentioned today. All right, so we're always happy to get feedback. As I mentioned before, we try to incorporate feedback as much as possible. It's not always possible, which is very unsatisfying for us and for contributors as well. But we do our best, and we try to document it so we can apply it in the future, even if we can't apply it as soon as we'd all like. There are several ways to provide feedback. A couple of them are provided here. If you want to, for example, give me feedback on my presentation today or on work of LANDFIRE, you can go to email helpdesk@landfire.gov. And Jeannie Patton, who is on the call today and who helped make the slides compliant and do some copy edits and much more, she'll send that email out to the appropriate person. Also, landfire.gov has multiple ways to connect. And Megan Sabaski has a Northeast LANDFIRE Google group. If you Google for that, you'll find it. It'll come up right away. So tons of ways to interact with us. And additionally, it's just we have several links and ways to connect. If you want to be a little bit more passive, you can go to our Twitter account and follow news and learn about uses of LANDFIRE there. I mentioned our YouTube channel earlier. There are several tutorials on how to work with grid data or perspectives on LANDFIRE there. And we also have these other links. I also see there have been some great chat on the side there, and I really appreciate you guys for that. It looks like Megan and others have pitched in to help answer questions, which is super, super appreciated. And with that, I'll open up the floor for questions, ideas, and thoughts you might have. Jack, if you can do that, I think I'm ready.
Sure. Yeah, there's a lot of information here, so let's so people can kind of go through the chat box and see a lot of the links that Megan put out there. And then near the bottom, Jeannie reminded everybody that we are going to need your name and affiliation and email into the chat box. You don't need to type that right now. We'll leave it open near the end. But if you want the documents from LANDFIRE, you're going to need to type that information in so that we have that. And then if we go into the chat box, let's see, at the top, I think one of the first questions we had, and I'm not sure if we addressed or not, came from Bob. And he says, sorry, I'm confused. There was a parameter in the Laurentian pine barren that had fuel height labeled 0 to 50 meters, it should be. And the question was, doesn't every single fuel type we have fall into that category? Because even with the 0 to 50 meters, there aren't many white pines that are getting 50 meters in an entire region. You see that one, Ryan?
Yeah, that one. Yeah, and thanks for that question. So the LANDFIRE height data is broken into bins, 0 to 5 meters, 5 to 10, 10 to 25, 25 to 50 meters, and 50 plus. And again, we're hoping to separate those out more with the LANDFIRE remap, but each pixel is given one of those labels. And again, as you know, there are not very many 50 plus meter pixels in the Great Lakes at all. So in the LANDFIRE fuel calibration workshops that I did not attend, so I'm just kind of reading into what I've seen so far, they did not distinguish a fuel type based on height for the Laurentian pine barrens. Instead, if my memory serves me correctly, they did give the same fire behavior fuel model for basically all undisturbed Laurentian pine barren pixels. And that's one reason why the Huron-Manistee did the calibration workshop, which was to look at separating those out based on cover. So cover was the distinguishing point for them in one of the examples I showed. So maybe that's part of the answer there.
Okay.
Looking at a couple other questions.
Yeah, what I did is I also copied two messages from Lisa Saperstein and then Henry Bastian but it's all rolled under mine. So Lisa just mentioned she used the few models, FBFM 40 or the Canadian fuel types, responding back to your question. And then I guess if you can read Henry Bash, and just to make sure, I believe you covered it all.
Okay, but great point, Henry. Thanks for reminding us of that for sure. Then I want to highlight something, a comment by Tim Baker. Thanks for that on the Hiawatha National Forest. I probably made it sound like the boundaries were proclamation or ownership boundaries for the Hiawatha National Forest, and that's not correct. As Tim points out, we did extend the project area outside the boundary, and the vision for the future is to do this work for the entire Upper Peninsula. As you know, it's hard to know where to stop and start. It's sort of like doing a remodel on your house. You go to paint, you realize you got to patch the drywall, then you, oh man, we might as well replace the drywall. Oh, look at the crazy electrical behind the drywall. It's hard to know where to stop, but Tim is right. We did buffer the Hiawatha National Forest to try to get at what might happen as fires come into the forest from outside areas, and we do hope to broaden the analysis for the entire Upper Peninsula in the future. And Jeannie and Jack, thanks so much for your mention of emails. I'm not seeing a lot of chatter on that. Maybe you guys are sending notes to them directly. I had forgotten that this interface does not collect your emails, so I was assuming we had your emails, but we do not. So you may have been taking great notes or don't need these tools, but if you're interested, we're going to send out a document later with links and more information. So if you're interested, do send us your email for that.
Yeah, it looks like there's a couple options here. If you want to type your name, affiliation, and email into the chat box, I can get that to Jeannie. Otherwise, Jeannie said you can email direct to landfire@tnc.org, or you can email Megan also in order to get this document.
And I will again implore you, this is my first time giving this presentation. I'm stretching and I'm leaning on the work of many others, so I would love any feedback you have on the presentation itself. You can send that to landfire@tnc.gov or myself or Jack, and he can probably make it anonymous if you don't want to share it in a personal way. But I am interested in your feedback for sure.
Yeah, definitely. It can always improve. So looks like we got a bunch of people typing in their names and emails, so I'll be able to get that to Jeannie. And we have time for more questions too, if anybody has additional questions. We'll have to watch through the flurry of typing of emails. Get a bunch there. I'm not seeing any more questions yet. Hopefully a few more typing. Randy, any thoughts?
Not at the moment. Just really appreciative of the work you guys do, and the more I learn about the fire behavior fuel models, the more humbling it is that you guys out in the field try to understand this stuff at any big scale. It's very complicated.
Definitely. Well, you did a great job, and you're getting some good jobs from Don and from Henry and others. So I guess with that, I'll leave the chat box open here in case people want to type in their email if they haven't had a chance. Otherwise, we can close this up. From my end, for the Lake States, we do not have any webinars planned until October. That doesn't mean we might not have a surprise one coming out, but otherwise our 2018-2019 series starts in October. So that's mine. Randy or from the LANDFIRE team, do you have any additional closing remarks?
No, just thanks everyone for your participation and questions and work out there in the field and with the data sets. Thanks so much.
Yeah, thanks everybody, and thanks Randy. And I will make sure we are recording this, so they'll be recording the presentation that's up on the website. It should be up in the next few hours. There's also a PDF of the slideshow that Randy just went through, and I'm sure that Jeannie from LANDFIRE and Megan will also be spreading this or making the recording of links available if needed too. And before we close, I just want to make sure that should be good. All right, well, thank you, everybody, and we look forward to seeing you at the next webinar. And Randy, thank you so much. Wonderful job.
Hey, you're welcome. Thank you, everyone.